JavaScript was once called the most ugly language, but it has evolved significantly over time. Thanks to a rich and resourceful ecosystem, it is now considered the most popular programming language. Some even say it will eat the entire internet. But today, we aren't just here to praise it. The most important factor that transformed JavaScript into the powerhouse it is today is its asynchronous behavior. To work with JavaScript at an advanced level, you first need to understand this concept. In this video, I will give you a clear idea of how asynchronous JavaScript works so that you won't have any more confusion. By nature, JavaScript cannot perform multiple tasks at once. It runs one operation at a time, which is why it's called a single-threaded programming language. What does that actually mean? Let's imagine a restaurant scenario. Suppose a restaurant has 2 tables and 1 waiter. The waiter goes to table 1, takes the order, and goes to the kitchen. Until the food is finished cooking, he remains blocked. Only after serving customer 1 does he become free to go to customer 2, take their order, and wait again. By default, JavaScript works exactly like this. The customers are the users and the waiter is the thread. This is synchronous blocking behavior. It's called blocking because the thread stays idle while waiting for a task like cooking to finish. Let's see how this looks in code. Imagine a function called Promise.order that takes a long time to complete. When JavaScript runs, it might first print take order for customer 1. Then it calls Promise.order. Inside that function, it prints processing order for customer 1. But then it hits a while loop running for 3 seconds. While that loop runs, JavaScript cannot move to the next line. It stays blocked, just like our waiter. After 3 seconds, it finally prints order processed for customer 1 and moves to the next line to print completed order for customer 1. If a user encounters this in a real application, the interface would freeze, which is a terrible user experience. This is why asynchronous JavaScript is absolutely necessary. Before we dive into that, we need to understand how JavaScript runs inside the browser. When the code runs, it is converted into machine language by the JavaScript engine. While different browsers have different engines, like Chrome's V8, Internet Explorer's Chakra, or Firefox SpiderMonkey, Google Chrome is considered the most powerful because of the efficiency of the V8 engine. Inside the browser, there are 2 main components: the runtime environment and the engine. The runtime environment provides objects like window, document, and setTimeout. Inside the engine, the most important part for us is the call stack. JavaScript execution begins with a main function. As the code runs line by line, functions are pushed onto the call stack. For example, console log is pushed. It prints to the console and then it's popped up. When it hits the process order function, that goes onto the stack. If there is a 3-second while loop inside, the call stack remains occupied. The browser is blocked, the user can't even click a button. This is the last in, first out or LIFO nature of the stack. Now, let's see how we can remove this blocking behavior by replacing that while loop with a built-in function called setTimeout. In this version, JavaScript behaves differently. When it reaches setTimeout, it recognizes it as an asynchronous function. Instead of waiting, it hands the task over to the web APIs, which is the part of the runtime environment, and immediately moves to the next line. While the 3-second timer runs in the background, in a separate thread provided by the browser, the main thread continues executing the rest of the code. This is why you will see other logs print instantly while the cooking happens in the background. Once the web API timer finishes, the callback function, that means the arrow function inside setTimeout, is set to the callback queue. Here, the event loop comes into play. Its job is to watch the call stack and the callback queue. When the call stack is empty, the event loop takes the first task from the queue and pushes it onto the stack for execution. This is how JavaScript performs multiple tasks despite being single-threaded. It has assistants. This non-blocking approach ensures the user can still interact with the UI while heavy tasks happen in the background. However, this creates a new challenge: flow control. With setTimeout, we can predict the 3-second delay, but in real life, we deal with API calls, file system reads, or database queries. We don't know exactly when those will finish. If we can't control the order of execution, it becomes a problem because the sequence of tasks is often critical. Let's go back to our restaurant scenario. Now, the waiter takes customer 1's order and tells the kitchen, call me back when this is ready. Then he immediately goes to table 2. He isn't blocked, he is free. When the kitchen calls him back, he finishes the order. In code, we handle this using callback functions. By passing a function into another function, we can ensure that complete order only runs after process order is done. This works and it's non-blocking, but it leads to a problem called callback hell. As you add more tasks like complete order 2, 3, and 4, the code nests deeper and deeper, becoming unreadable. To solve this, JavaScript introduced promises. A promise is exactly what it sounds like, a promise to do something. It can be resolved or fulfilled and rejected or failed. To use a promise, we use then for success and catch for errors. This is much more human-friendly. Then literally means after. We can also chain promises together. If any promise in the chain fails, the single catch block will handle the error. This is much cleaner than nesting callbacks. Sometimes you might want to run multiple promises at once. For that, we have Promise.all, which waits for all of them to finish and returns an array of results. There is also Promise.race, which only returns the result of the promise that resolves the fastest. While promises are great, chaining many then blocks can still get messy. Programmers prefer writing code that looks synchronous even it's asynchronous. This is where async await comes in. By adding the async keyword to a function, it automatically returns a promise. Inside an async function, we can use the await keyword. Await tells JavaScript to wait for that specific asynchronous task to finish before moving to the next line. Even though it looks like it's waiting, it's not blocking the main thread. JavaScript skips the myMeeting function call and continues with other code, returning to finish the function once the data is ready. We handle errors in async await using standard try-catch blocks, which makes debugging very intuitive. To summarize, for the best performance, always aim for asynchronous non-blocking code. Use callbacks for simple tasks, promises to manage more complex flows, and async await to keep your code clean, readable, and organized. I hope this clarifies the concept of asynchronous JavaScript for you. If you have any questions, feel free to comment.